All right, guys. Let's oh, excuse me. Let's go ahead and get started on our review. These are a couple questions that you could sort of expect to see something like on the quiz, or excuse me, the test that is coming up on Friday. I'm going to be re-going over this one. There's a little bit of confusion in eighth period, and I think it would be good just to have a really thought out, way throughout this problem. And then these two down here are two new ones, and I would expect to see something close to them, or close to one of them at least. Why is my... There we go. So let's move this stuff on down and get started with our two-column proof. So as always, we're going to start with our statements and reasons. And first and foremost, let's look at what we're trying to prove. We're trying to prove that the measure of AOE, so that's this angle, is congruent to 2 times BOF. So essentially 2 times this angle measure. So we need to find a way to relate 2 times BOF to something. Now, one thing that we could also note is that we have a pair of vertical angles here. So this green angle, BOD, is going to be congruent to AOE. So that's something that we could potentially use in the near future. Okay? We also have this fact that BOF is congruent to FOD. So let's go ahead and start with that. This BOF is congruent to FOD. So our first statement and our reason is, of course, given. The next thing that I am going to do is I am going to use this fact to try and get that 2 BOF into here. I know from the angle addition postulate that this angle plus this angle is equal to this whole angle, the green angle. So that's what I'm going to introduce now. So 2 is going to say, or use the angle addition postulate to be able to do that. So we're going to have measure of BOF plus the measure of FOD is equal to the measure of BOD. And our reason here is, of course, the angle addition postulate. So now we have defined this. The next thing that I want to do is talk about or introduce somehow 2 BOF. So what I can do is note that these two things are equal, so I can substitute BOF for FOD and vice versa. So I can rewrite measure of BOF plus the measure of BOF is equal to measure of BOD, and the reason is substitution property of equality. Property, note that it's not congruence in this case because things are equal, not congruent. And the next thing that we're going to do is we're going to introduce that 2M BOF. This is just combining like terms because I have 1 BOF and I have 2 BOFs. It's like saying x plus x is equal to 2x. That's essentially what we're doing. So 2 BOF is equal to the measure of BOD. Now we can say, the reason is combine like terms. Now our next order of business, so we've related the green angle to BOF. Now I need to relate this AOE, this orange angle, to the green angle. So how do we do that? That's going to be vertical angles. And remember one thing about vertical angles is that vertical angles are congruent. They are not equal by the vertical angle theorem. They're congruent. So this is the vertical angle theorem. But now I'm dealing with an equal and a measure here, and I have a congruent. So I have to change one of them essentially to equals. So I'm going to rewrite our last statement as a measure. The measure of BOD is equal to the measure of AOE. And the reason is congruent angles have equal measures. So now I've related the orange angle to the green angle, and I've done all this good work. And remember what we're trying to prove? We're trying to prove AOE is equal to 2 BOF, or excuse me, the measure of AOE is equal to 2 times the measure of BOF. So notice I don't have an angle sign there. So I have 2 BOF is equal to BOD, and BOD is equal to AOE. So we can go ahead and finish this out using the transitive property. Because they're both equal to BOD, I can set them both equal to each other through the transitive property. So this is transitive property of equality. Okay. So technically speaking, we could also use substitution down here. That's fine, but this is just what I chose. So we should have some amount of statements like this. In 8th period, I do remember that we switched between the equals and the concurrent. We bounced back and forth a little bit, maybe too much. So that's something I apologize for. But let's go ahead and move on. Let's get rid of all this stuff so we could just see the problem by itself. And we'll move on. So let's look at this next picture. We are given that angle A is equal to BPA. Oh, that's actually definitely BDA. So angle A is this, and BDA is our orange. And all I want to prove is x is equal to 5. Okay, so that's going to be our last statement. The other thing is I know nothing about BDA, but it does have a vertical angle to this thing where I do know the measures. So that's probably where I'm going to start here. So let's go ahead and draw our table once again with our statements, our reasons. And of course, as always, we are going to start with our givens, or given in this case, or one given. So now what I will need to do is I don't have any angle measure for BDA, so I need to be able to relate that to something. So I'm going to use vertical angles and say that BDA is congruent to CDE. So 2 angle BDA is congruent to angle CDE. The reason is our vertical angle theorem. Okay, vertical angle theorem. Now what we can do is I'm going to have to introduce a measure because these are measures, so I do have to swap into equals. So our measure of BDA is equal to the measure of CDE, and this is because congruent, that definitely wasn't spelled right, congruent angles have equal measures. So now, one thing that's kind of weird about this is if we do have a diagram, we don't have to write it down as a given. So I say that BDA, or the measure of BDA is congruent to the measure of CDE. We know that the measure of CDE is 12x plus 15. So we could just go ahead and now state what BDA is equal to, the measure BDA. So let's go for measure of BDA is equal to 12x plus 15. And the reason we can do this is just via the diagram. Just via the diagram. Now let's keep in mind what we want to prove. Oops, excuse me, we want to prove that x is equal to 5, so I need to relate this to this. So I'm also going to introduce that 5, that our measure of angle A is equal to what? 11x plus 20. 11x plus 20. And this is also the diagram. I have this statement that A is congruent to BDA, but what I need to be able to do is have them be equal and have measures. So I'm going to create another statement that says measure of angle A is equal to the measure of BDA, and the reason again is this congruent angles have equal measures. Brought a G down, unfortunately. Okay. So now I have all these, or hold on, let me see. But now I have measure of angle A and measure of BDA. And I have this, so I can use substitution to go ahead and bring down the angle measures. So I'm substituting measure of angle A for 11x plus 20, and then I'm going to have BDA is equal to 12x plus 15. So you can see where we get those from, because we've defined those variables and those items up top, up here. And this is substitution property of equality. And now we just do our math. So in kind of one step, I'm only using the subtraction property of equality. Basically what I'm going to do is I subtract 20 from both sides. Wait, nope, I don't want to do that. I want to subtract 11x from both sides, and then subtract 15x from both sides. So basically what I'm going to be left with is exactly what we want. We're going to get x is equal to 5. And the reason is our subtraction property. Subtraction property of equality. And once again, note that that is exactly what we are looking for. I want to prove x is equal to 5, so we're good to go. Let's go ahead and erase all of our highlights so we can see exactly what's going on, all of our other markings, and this stuff too. And we are good to go. So this one was kind of a long one because we had to do a lot of introducing things, as well as flipping back and forth between congruent angles and that sort of thing, as opposed to equal angles. So let's look at our last one. So given 3 and 7, so 3 and 7 are congruent. I want to prove 2 and 8 are supplements. Okay, so 2 and 8 are supplements. So I want to prove that red things are supplements. So sounds like a lot of fun here. So we start with our statements and our reasons. And our first statement, as always, is given, so angle 3 is congruent to angle 7, and the reason is given. So let's think about what we need. So I need to relate angle 2 to something, and I need to relate angle 8 to something. And the stuff that we know about is going to be the most helpful to relate it to. So I'm going to start with angle 2 and 3, because I believe that's the most simple thing. So let's start with 2. I'm going to say angle 2 is congruent to angle 3, and the reason is vertical angles, because they're straight across from each other, and they have straight lines as their rays. So this is going to be our vertical angle theorem. The next thing that we can do is say that 7 and 8 are supplementary angles. So 3, angle 7 and angle 8 are supplementary angles. And what is the reason for this? Definition of supplementary angles. Definition of supplementary angles. Basically what that says, if two angles sit on a line, they're supplementary. So now let's keep in mind what we want to prove. We want to prove 2 and 8 are supplements. And do we have enough information at this point to be able to do that? Let's go and think about it. In the back of your mind, you should be thinking that we're going to be using our congruent supplements theorem, which basically says if two angles are congruent and one of them is supplement to another angle, they're both going to be supplements. So now what I actually want to do here is I want to relate 2 and 7 and say that those are congruent as well. Because I know that 7 and 8 are supplementary, so if I say 2 is congruent to 7, I'll know 2 and 8 are supplementary. So we're going to have 4. We're going to have 2 is congruent to angle 7, and the reason why, you could see up here, we could do the transitive property of congruence, because 2 is congruent to 3 and 3 is congruent to 7, so 2 is congruent to 7. So transitive property of congruence. I teach math, not spelling. So I have 2 is congruent to 7, and 7 and 8 are supplements. So that means by the congruent supplements theorem that 2 and 8 are supplements, which is exactly what we want. So we can copy, not group, I don't want to group it. I want to copy, paste, and our 5. And the reason is the congruent supplements theorem. Okay, so I'll give you a second to look at this. Let's erase all my markings up here so we get a full picture. And we're done. Notice in all these, remember we have what we're trying to prove at the bottom left. What we're trying to prove, x equals 5, 5 equals x at the bottom left. And then 2 BOF is equal to AOE, same thing. So this is going to serve as a review. We're going to do a few more. You'll probably be watching this after school on Thursday, would be my guess. So in class, we would have done a couple more review questions, maybe gone over some more of the homework, and done some stuff with some algebra, but I like calling it algebra. So anyway, happy studying. I'll try to be here Friday morning pretty early, so if you guys have questions, comments, concerns, I'll be available today, or if you're watching this during school, Thursday. I do have to leave at about 3:20, unfortunately. I have a new teacher new teacher meeting on Thursdays, like once a month. So that just happens to be today. So if you got any questions, send me an email, and I'll see if I can get back to you. Other than that, I'll try to be here pretty early. I'm talking like 7:30, 7:20 tomorrow. So